can you solve this math challenge? Here's the question. So, our goal is to solve for the values of x and y. Given this equation, 72 raised to the power of x times 48 raised to y equals 6 raised to the power of x, y. You can pause this video if you want to give this problem a try. And now, let's answer this question together. So, our goal in this question is to solve for the values of this x and y that satisfies this equation 72 raised to x times 48 raised to y equals 6 raised to the power of x, y. So, how are we going to answer this kind of question? First thing is to notice this 6. This 6 can be factored as 2 times 3. Now, our plan is to factor out 72 and 48 in terms of 2 and 3. Then let's compare this exponent. Now, let's do that. Take note that if we have AB raised to the power of C, this can be written as A raised to C multiplied by B raised to the power of C. So, 2 times 3 raised to xy can be written as follows. We have 2 raised to xy times 3 raised to xy. Now, let's use some factors of 72 that contains 2 and 3. Now, this 72, take note, this 72 can be factored as 8 and 9. And this 48 can be factored also as 16 times 3. Now, take note, this 8 can be written as 2 raised to 3. And this 9 can be written as 3 raised to the power of 2, or 3 squared. Also take note, this 16 is a multiple of 2, so this can be written as 2 raised to the power of 4. Now, we can now apply this law of exponent to this term, so this can be written as 2 raised to 3x times 3 raised to 2x. Also, this factor right here can be written also as 2 raised to 4y times 3 raised to the power y. Now, we have a common base of 2, so let's rearrange some terms a little bit. And now, let's use some laws of exponent again. Take note that when we have the same base, b raised to a times b raised to the power of c, we have different exponent. So we can rewrite this as b raised to the power of a plus c. So we can add their exponent. Therefore, we can simplify this 2 raised to 3x times 2 raised to 4y into 2 raised to the power of 3x plus 4y, or the sum of their exponent. Also, we can rewrite this 3 raised to 2x times 3 raised to y into 3 raised to 2x plus y. Now, here comes the good part. Because take note, this equation is equal. Take note that the exponent of 2 on the left side must be equal to 3x plus 4y. And the exponent of 2 on the right-hand side must be equal to xy. So we can say that 3x plus 4y must be equal to xy. Also, another equation must be 2x plus y must be equal to xy, or the exponent of 3 on the left side and on the right-hand side. So we can say that 2x plus y must be equal to xy. Now, let's use these two equations to solve for the values of x and y. Now, take note that both equations must be equal to just xy. So we can say that 3x plus 4y must be equal to 2x plus y. And now, let's rearrange some terms a little bit and solve for the value of x in terms of y, or y in terms of x. Now, 3x minus 2x, this is just x. And y minus 4y, this is just negative 3y. So we can say that x must be equal to negative 3y. So what we're going to do here is to choose one of this equation and solve for the value of y. Now, let's use the second equation because we only have two in its numerical coefficients. So this is more simple than the first one. So let's use this. And now what we're going to do is to replace all of this x by negative 3y. So let's do that. So we have 2 times x or negative 3y plus y equals this is x or negative 3y times y. Now let's simplify. 2 times negative 3y, this is just negative 6y. And negative 3y times y, this is just negative 3y squared. And negative 6y plus y, this is just negative 5y. And let's add 3y squared on both sides. So this will give us 3y squared minus 5y equal to 0. Now take note that we can factor out a factor of y in this two term. So we can do that as follows. So this can be written as y multiplied by 3y minus 5. Take note that when we distribute this y, this is just 3y squared and this is just negative 5y. Now, since it is equal to 0, follows that at least one of them must be equal to 0. So we can say that y equals to 0 or 3y minus 5 must be equal to 0. On the first equation, we can already solve for the value of y must be equal to 0. On the second equation, if we solve for the value of y, we get that y must be equal to 5 over 3. Now, we found the values of y can be 0 or can be 5 over 3. Now, to solve for the value of x, take note that x must be equal to negative 3y. So, given this case that y must be equal to 0, if we replace this y with 0, negative 3 times 0 will give us the value of x must be equal to 0. So, if y is 0, x must be also equal to 0. So, this is our first pair. So, this is the value of x and this is the value of y. Now, if y must be equal to 5 over 3, and we replace the value of y to this y right here, so we have negative 3 times 5 over 3, the value of x must be equal to negative 5. Therefore, our answer to this question, we have two possible pairs of x and y. If x equals to 0, then y equals to 0. Or if x equals to negative 5, then y must be equal to 5 over 3. And as always, we are done.